Hi everyone, Jonathan here. Hope you guys are doing great and are taking good care of yourselves. Now, I've made some deployment videos on how to deploy FastAPI, Flask, or Django applications to the cloud. And most of them have been videos on using platform as a service tools. In this one, I want to use something different. I want to deploy an application on Amazon EC2. Now, I've done this offline and I've organized all the steps that I took. I'm going to be doing the same steps so that you can at least understand my kind of reasoning when it comes to carrying out this task. Now, if you find this video helpful, please leave a like, and also do not forget to share some more things you think will be useful specific to this topic. Without wasting time, let us get into the video. All the steps we're going to follow in this video are going to be located in this document. I'll make sure that I leave it down in the description so that you can follow it and use it in whatever way you want. So the first thing we need to do is to set up a simple server. I am on AWS and that's where I'm going to get my server, but you can feel free to get your server from Linode or another platform that can give you our Ubuntu server. And the service that I'm going to be using to create that server is going to be the EC2. So EC2 is the specific AWS service that provides you virtual servers in the cloud. So these are virtual machines or virtual private servers or VPSs that you can use to create servers or create instances of servers which you can deploy your things on. In this video, I'm going to be deploying a simple FastAPI instance. So this is the EC2 dashboard right here. There is so much to it, but when you come to this instance or when you come to this page, the most important thing we're going to look at is the launch instance button. And this button is going to allow us to create an instance of a server. We're going to be prompted for specific details like the name of the instance we want to create. So I'm going to call this our simple FastAPI app. And once I'm done with that, I'll scroll down, select an image of the OS I want to use. I want to use Ubuntu. So that's the kind of server I'll use since that's what I'm really familiar with. And then you can also have like options for Amazon Linux, Mac OS, Windows, Red Hat, and so on. After selecting the specific type of server I want to use, I'm going to scroll down and I'm going to also set the instance type. Now the instance type I'm going to be using is the T3 Micro, which is free tier eligible. That comes with 1 GB memory and some other provisions, but I feel that will be enough for us to use for our simple demonstration. There are also other paid versions like the T3 Nano, T3 Small, T3 Medium. I'm going to be using the T3 Micro. So once that is done, I can go ahead and create my key pair. So this key pair is going to be very useful as it's what is going to help us to access our server through SSH, and we can be able to perform actions in our server locally on our machine. So I'm going to click this create new pair button and I'm going to give this a name. So I'll say this is going to be, let me give it a name that doesn't have FastAPI in it. Let me say API, let me just say simple keys. And once I've done that, I can choose the key type. I'll leave it to the default. I'll say RSA, but you can also leave it to ED25519. I'll just leave it to RSA. And now you can set your key to be either one you can use for OpenSSH like we're going to be doing, or one you can use for that program called PuTTY, which is a graphical interface through which you can interact with your server. So after creating our pair, it will be downloaded, and this is going to be in my downloads right here. So I'm going to create a folder and I'm just going to call this my keys, and I'll move that keys inside that folder. So once I'm done with that, I'll close that, and then we shall have our key set up. So another thing that's important is we need our server to be accessed on the internet. So we need to come to the network settings tab right here. We shall leave everything to the defaults except for that one option of allowing HTTP traffic from the internet. So this will make our server accessible from wherever we are on the internet, so that requests can be made to the server and stuff like that. But if we leave it to the defaults, we can use the server, but we cannot be in position to make requests to the server, so it will not be accessible. And the defaults will be those. So once we are done with that, I'm going to just simply go down here and click on launch instance. It will take some time, but once the instance has been launched, we shall be given instructions on how to connect to our instance. So after creating our instance has successfully initiated. So let's go ahead and connect to the instance. That will open up a new page right here, on which we shall access some guidance on how we're going to connect to our server. So right here, I have a simple terminal, and this is a simple Nginx terminal. It's what I'm going to be using throughout this video to interact with our server that we've set up on AWS. So what I'm going to do is to come right here. There's a bunch of stuff here. This is the instance ID, the VPC ID, security groups, blah, blah, blah. But you can see a lot of tabs right here. You see the EC2 instance connect. You can see some details here, like the IP address of the server we're going to be making use of. But what I prefer to do is to come to the SSH client section right here, and then I'll follow these details because they are quite easy to follow. So the first thing we're told is to open up an SSH client, locate the private file. So in my terminal, I'm going to navigate to downloads and then keys, because that's where we placed our simple keys.pem or .pem. And once I've done that, I'll then go ahead and do some permissions stuff to change the permissions and make that key have the right permissions for SSH to use it to connect to our server. So I'll go copy this command, come to our terminal, I'll say chmod simplekeys.pem. That will change the permissions of the file. And then the next thing will be for us to use that to connect to our instance. So the command for that is ssh-i. So this is basically to specify or identify the key we shall use for the connection. And that's going to be our simplekeys.pem. The user or the default user of our server is going to be Ubuntu, and then the domain, which is going to be like the IP address of the server we are going to connect to. So when I press enter, we shall be told the authenticity of this can't be established, blah, blah, blah. The key is not known by other names. Are you sure I want to continue connecting? We shall say yes. And now the address will be added to our list of known hosts and shall be in our server. So once we are here, the next thing we're going to do now is to play around with our server. How? We're going to first of all run some updates. So I'll say sudo apt update, and so I'm going to run an update and an upgrade. So I'll say sudo apt upgrade. So that will just go ahead and install a bunch of stuff, run updates, and then run upgrades. Okay, so once that is done, then our upgrades will be done. There's a bunch of stuff we are being told right here. No VM guests are running outdated, hypervisor binaries on this host. Seems like everything is running fine. We have entered our server, run some updates and some upgrades. Now, the thing that's going to be the next is to set up UV, because that's the package manager we're going to be using. And I'm going to go ahead and copy the installation instructions. So I'll head over to the UV documentation, and that's where I'll get the command for installing UV. Since we're working directly on our server, it will be just okay for us to go ahead and just install UV on our system. So I can go ahead and copy this command. What this does is to fetch the installation script and execute it. So I'll go to our terminal right here, paste this command. It will install UV on our system. So things are a little bit fast because the internet is fast in the server. That's why you see that we have our UV installed, but for it to work, we have to sort of like refresh or restart our shell. So I have this thing that I usually do where I just type shell, and then if I do that, we now see our UV is installed. If I also try that with UVX, I'm so stuck with the CLS because I have that as a bash alias in my terminal. But what I'll do is to Control L to clear the terminal. If I run UVX, now that will also show us that we have UVX installed. So both UVX and UV have been added to our server. Another thing I'm going to go ahead and install is going to be the Nginx. Nginx is a program that can perform quite a lot of tasks. It can be used as a web server, a reverse proxy, a load balancer, and very many other things that I may discuss in future videos. But for this video, what we're going to be making use of it is to allow us to run our app locally on localhost and then expose that on the internet. That's exactly what we're going to make use of Nginx. To install Nginx, we're going to run the following command. We're going to run sudo apt install Nginx. Now to go ahead and that will be it. We have Nginx now installed. So according to my document right here, once we've installed Nginx, we can enable it so that it restarts when the server restarts and it stops when the server stops. So I can do something like sudo system control service, or this is actually start nginx dot service, and then we can also enable the service. So we can say something like systemctl system control enable Nginx. That will enable Nginx. So we can also check the status of Nginx by running the command status. So Nginx is active and running, which is fine. And that will be it. We have our Nginx and we have set up our UV. Now it's time to do some serious work. In the ideal world, you're going to have your application hosted on, let's say, GitHub, where you'll fetch the code and then set up the code. So let's go ahead and do exactly that. So what I'm going to do is to open up a new project inside this folder in which I have the steps.md file. So I'll leave this in that link in the description. First thing we're going to do is to go inside my terminal right here, and let me actually just go to my terminal. I'll open up a new tab. So I'll just cd this and take it to where I have this simple Flask deployment. So I think that is in my documents folder under the Flask simple deployment folder, which I'm actually doing FastAPI simple deployment. So I'll navigate to that. I'll say cd documents, Flask simple document, and that's where I have this steps.md file. So the first thing I'm going to do is to create a new FastAPI project inside here. I'm going to be using the UVX FastAPI new command. If I run this without specifying that directory in which I want the project to be created, to go ahead and use the current directory in which we are, and we shall have our FastAPI installed, a project set up, so that we can just basically run our FastAPI project. So once this is done, we can now just simply go ahead and run our FastAPI app. So if I take you to our VS Code right here, we have some more files. We have main.py, the file that has our simple FastAPI app. We see the FastAPI instance created and a simple endpoint created that returns a response of hello world. We have a PyProject.toml file that has metadata of our application as well as the dependency list. A readme.md file with instructions on how to run and deploy our app, and the stepsmd, the UV lock that locks our application to a specific set of dependencies. Now, once we have done this, let's go ahead and try to simulate how we shall run our server in our application. So to start, we can just simply do uvrun FastAPI run, and that will be enough for us to run our application. That is how our application will run. And if we go to localhost 8000, this time we shall see our response being returned of hello world. Now the interesting thing is this is run on 0.0.0.0, which means all available IP addresses, but in a real server we don't want that to happen. We want to run the application on localhost, and since we're going to be making use of Nginx, we shall then point that localhost to route through Nginx to the server's IP address or to the domain so that we can access our application. So once this is done, we can now go ahead and also see some other options. So if I do uvrun FastAPI run and then say --help, we'll now see this should be uvrun FastAPI run. So this will point us to some of the options we have. We can specify the host and the port. So the command we're going to be using instead is going to be uvrun FastAPI run, and then our host is going to be 127.0.0.1, and then the host will be, which is actually going to be the port. So our port here is going to be port 8000. So that will run our server on localhost. So keep this command in mind. It's what we're going to be using in the Nginx. So it's what we're going to be using to create a daemon or a process that will run our application every time our server will start. So that is how we're going to be running. So once we've created this simple application, you can create other simple routes. For example, if I come here, I can create an about route. So once that is done, we can now commit our code to GitHub. So the first thing is going to be for us to create a .gitignore. So I'll just come right here and say .gitignore, and then I'll add whatever I do not want to make it to GitHub. So I'll say I'll add the .vim folder, which is our virtual environment. I'll then go ahead and add all PyCache folders, and then followed by all that .pyc and whatever. You can even make use of something like gitignore for Python. So let me just copy this. It includes most of the stuff that will be ignored in a Python project. So that's very important in case you don't want to do a lot of thinking and you just want to copy it, paste it, have most of the things you are ignoring ignored. So I'll copy this. I'll add this right here. And then we shall be good to go. So now we've created our app. We've set up our server. Now we're going to go ahead and push our code to GitHub. So what I'm going to do is to run the command git init. So let me do this in our terminal. So in our terminal right here, where we have our simple Flask deployment on our machine, I'm going to go ahead and initialize a new Git repo. Once we've created our Git repo, I'm going to stage all the files to our repository, And then I'll create a commit to keep track of the changes. So I'll say git commit m initial commit. Once that is done, we can now go ahead and create a GitHub repository. I'll go to my GitHub. And on my GitHub, I'm going to navigate to repositories. I'll create a new repository. And then I'll just say simple FastAPI deployment. Let me just actually make this have some dashes. Simple FastAPI deployment. And then I'll add a description later. I'll leave the repository public. I'll create the repository. And we'll be good to go. Now, the next thing I'm going to do is to copy this URL right here. And it's what I'm going to be setting as my remote repository URL for the repository we're going to host this code on. So I'm going to come right here and run the command git remote add origin, and then I paste the URL. So it seems like that remote origin already exists. I think I'm running in our repository that's already existing. So let me run the command git push uorigin main. Now, one thing I hate is that I always have to run this in my VS Code because for some reason I can't directly run it in my terminal. So when I sync changes, that will update the code on GitHub. And when I go there, refresh, I think I already have such a file, or I already have such a repository. Let me check. So if I go here, I have simple FastAPI deployment. Oh, this is simple Flask deploy on Linux. Now let me see. Let me just rename this repository, or let me remove the repository, recreate it with another name. I think I was in a wrong terminal, if I'm not mistaken. Let me just repeat the entire process once again. So I'm going to come right here, remove this repository I had. I'll say rmrf.git, and then that will remove the repository. So I'm going to reinitialize my repository with git add git init. Sorry, I had to do this because I had another folder in which I was doing some stuff with deployment, and it's this specific folder for a Flask app. So yeah, just wanted to demo this with a FastAPI app. So git init, git add all, and then git commit, initial commit. We shall use our repository URL, and we shall be good to go. I'm going to just go here and press the sync or publish branch button. That will go ahead and update everything on our repository, but you get the drill of pushing code to GitHub. So that's exactly what we're going to be doing there. So once the code has made it to main, our repository will now have our code. So everything is fine. Now what I'm going to do is to go ahead and clone this code or clone this repo on our server so that we can finally set it up to run it within our server. So I'm also going to do something on local before we go to our server. So in our server, we're going to be using Uvicorn FastAPI run as the command to run our server, which is kind of okay. I actually thought we were going to install Uvicorn till I remember that FastAPI run actually uses Uvicorn to run our server. One thing that we may also note is we shall add workers. So these are processes that will kind of distribute work to help our server sort of like distribute work across all the cores that it has. And this also comes as a benefit that if multiple requests are made to our server, then our server will have all these worker processes waiting for those requests to be made. So yeah, that is one other performance thing we can provide to our server in production. So one thing to note is if I ran this server, let's say I just went ahead and said UV run FastAPI, we shall see that one worker process will be handling all the incoming requests. But if we run our server with UV FastAPI run, and then we specify the amount of workers, we shall have 4 processes all running on the same server, each waiting for a request. So that handles or parallelizes the entire thing. So yeah, that's one thing I also wanted to point out. Now, we have set up our server, we've set up some code, we've set up UV and all that. We've also pushed our code to GitHub. So that's where we're going to go back to our server. I'm going to go back to our simple server right here, and I'm going to check if we have Git installed. So we have Git installed by default on Ubuntu. The next thing we're going to do is to now clone the code that we've pushed to GitHub. So I'm going to come right here. I'll go to this button right here, click this link, come down here in my server in the terminal right here. I'll say git clone, and then so that will basically clone the repository. If I ls, we have a simple FastAPI deployment. And yeah, so let me sit into the folder. So if I want to have all these commands or have our app run on our server, all I have to do first is to run the command UV sync. Now, if I ls in here, we have the UV log, so we can just basically recreate or reproduce everything like we have it on our local host. If I run the command UV sync, that will go ahead and install everything we installed and shall have our app set up. So I can do something like UV run. We now see we have our FastAPI, we have our Uvicorn, and all the other commands that come as part of the UV or the FastAPI standard installation. So let's go ahead and run our server. If I do UV run FastAPI run, we'll now see our app running on localhost, but it will be exposed on 0.0.0.0, which is all accessible IP addresses, but that's not what we want. We want to go ahead and run it in the following way. We are going to run it using host as 127.0.0.1, and the port is going to still be the default port, which is port 8000. So I'll also add the worker processes. So we're going to add workers, and we shall provide the number as 4. And that will be how we shall run our app. So if everything starts, we shall see the parent process is going to be this, and then it will provide all the other processes 1, 2, 3, and 4. Nice. So yeah, this is how we're going to be running our server on localhost. Now the next step is to go ahead and create a service or a daemon that is going to be running our app persistently every time our server is going to be running. So on Ubuntu, there is systemd, and that can help us to create services. So we can basically manually set up a bunch of things to allow this to happen, and that's exactly what we're going to be doing. I happen to copy a snippet of code that we shall make changes to allow our setup to happen. So I'm going to go ahead and run vim in a certain folder. I'll stop our server with Ctrl+C, and then I'll go ahead and run the following command. So if you're not familiar with vim, you can use nano, but I'm going to be using vim. So I'll say sudo vim /etc/systemd, and then /system. So in here is where, let me actually first of all ls so that I show you what's inside here. If I say sudo ls slash etc slash systemd slash system, we're going to see a bunch of services. So if you've been running commands like sudo systemctl start some service, then you're most likely to have a file that specifies how that service is going to run. So we need to create a file inside here that's going to define the daemon or the service that's going to persistently run our FastAPI application. So to do that, I'm going to run vim. So I'll say sudo vim because I need the sudo permissions to edit that folder. I'll say sudo vim slash etc slash systemd slash system, and then slash, let me call the service API. You can feel free to call it whatever you want. And in here is where we're going to paste that snippet, the one that I actually added. So I'm going to come right here. I'll copy this snippet right here. So this is going to be sort of like an INI format where we're going to have a bunch of stuff specifying how we want to run our service. So I'm going to come right here. I paste this file. I'm going to be told that pasting text is dangerous, but I'll paste it since I trust it. Now, the first thing we need to do is to go ahead and just edit a bunch of things, but I'm going to first of all edit the description part right here. So this is going to be our FastAPI app. And then I'll go ahead and simply leave after to network.target. I'll move and add the name of the user, the SSH user. So I'll just add this as my user, who is the Ubuntu user, the default user I have on this Ubuntu server. So let me remove these comments right here. Now, once I've done that, the next thing is going to be to specify our working directory. So the working directory is going to be where we want to simply make the service run from. And that's our application, or that's where we've cloned our application. And that's in our home folder, just like you can see right here. It's in our home/simple FastAPI deployment. So you have to get the spelling right. So the directory for that is going to be home/our user, who is the default Ubuntu user. And then slash the app folder, which is simple FastAPI deployment. And once that is done, we shall now go ahead and navigate to this part right here. We shall provide our environment. So the environment basically points to the folder in which all these executables that we shall need are going to be found. And if you are familiar with UV and have worked with UV, you'll understand that most of those are going to be found within your .vim folder inside the bin directory. So if I ls and run, let's say ls.vim bin, we shall now see all these files or all these executables right here that are going to be needed for the daemon to run. So we need to point it to that folder, which is going to be our folder for the user, who is Ubuntu, and then the name of the folder, which is going to be simple FastAPI deployment, and then .vim/bin. So that's where all these executables we can get by running UV run are going to be found. So I'm also going to remove this comment right here. Now, for our ASCII application, we're going to be making use of Uvicorn or another server, but it's also going to be in the format of Uvicorn main app. That's if your app is found in main, which is actually the command that FastAPI is using in the background. However, we can access that functionality through uv run FastAPI run. So instead of coming and saying uv run, we can go ahead and just simply point to uv run FastAPI run. This will automatically detect our FastAPI app instance. So we can just say FastAPI run, and then we shall leave the host to localhost and then the post to 8,000. I'll increase the amount of workers to 4 workers. And then I'll change our user to the Ubuntu user. And that will be it. So this is going to be the command the daemon is going to run to start the server process. So what it does is to make use of uv, which has the executable in the .local folder /bin/uv. So this is our uv executable. And then we shall run FastAPI run, provide the host as 127.0.0.1, which is our local host, and then keep the default port. Specify the amount of workers to 4, and then we shall be it. Now I also left a comment here that kind of guides you into how to do the same thing if you're using Uvicorn. So Uvicorn is the server that you're going to be using in case you are deploying a Flask app or a Django app or any WSGI or WSGI based web framework. So that's the command. You'll just point it to where UV is found, and then you run Uvicorn, point to where your application instance is found, and then you bind it to localhost 8000, which is like the same thing we have done right here. So once that is done, we have a bunch of stuff here. So the server always restart, and then we provide the amount of time it will take for the server to restart. So this is going to be 5 seconds. And then, yeah, that's our setup right there. So once we are done, we're going to save this. I'll exit my program by writing :W and then :Q to exit, basically saving and exiting the file. So that alone will be enough for us to have created that. So if we ls in etc systemd system, we shall now have our API. But let me rename that file to api.service. So I'll say sudo move /etc/systemd /system/API to /etc/system/API.service. So that's going to be a much better service name. And now we have our API.service right there. Okay, so once that is done, we can now go ahead and make systemd recognize and run the service as part of the other services it runs. The command for that is going to be the systemctl daemon reload. So that will kind of reload everything, and then we shall start our service, enable the service, and then check for the services status. So to do that, I'm going to come to our terminal right here. And what I'm going to do is to run the command sudo systemctl or system control daemon reload. So that will restart everything, and then I'll say sudo system control start, and then I'll start API.service. Now, since this exists in our etc systemd system, running this command will work. So we can go ahead and enable it so that we can run it every time the server starts with systemctl or system control enable api.service, and that will be it. So we can also check for its status. I can come right here and say system control status api.service, and now we see that it's active and running, which is fine. We can also see some logs right here. Our server has started, our startup is complete. We see our workers or our worker processes also set up just like you see right here. So I'll exit out of that using Q. All right, so we are good to go. Now, the next thing we're going to do is to run this command. So this is also another command we can use to check for the logs of our FastAPI instance. It can be helpful in case we want to see some errors. So if I run this, we shall see errors. I think I'm running this in the wrong place. This is supposed to be API. Sorry, the service is API, not. Let me try to go back here. So our service is. Let me try to go clear this. I'll actually just clear and then go back to the commands I've so far run. So this is api.service. Now, if I want to run, this is the API service. I'll say that, and then that will be just so good for us to see the logs that our app is going to be running. So if you're wondering what that command does, you can go ahead and run journal control -- help, and then we can see -u show entries not new, and then -u, this will show the unit, or it will basically show logs from a specific service, which is our API service for that case. I don't know why I'm typing CLS. I'm typing CLS because I set that up as a literal. I set that up on my machine as a literal clear command so that I type it faster. Okay, so let's go back to our server right here. So now, once we have set up our server, we set up the daemon or the process that's going to run our FastAPI application. The next thing is to go ahead and now set up Nginx. Just like I said, Nginx is just going to be performing the role of exposing the app we are running on our local host so that it's accessible on the domain of our application. So just like you see right here, it will handle public traffic coming in from clients on ports 80 and ports 443, and then it will serve any static files we shall set up, and then it will forward all those requests to our app, which is running on localhost 8000 on our server. So we have to edit a file, and that is going to be in the /etc/nginx sites enable available folder. So let's go ahead and do that. It's honestly hard to deploy on Linux. So if I go ahead and say sudo vim, I'll add that, and then I will /API. That's going to be the name of the specific configuration of Nginx. You can call it whatever you want, but I'm going to just keep it to API. If I enter here, I have some boilerplate I set up right here. So that's exactly what I'm going to add. I'll leave this in the description so that you can also play around with it. So if I paste this, we're now going to go ahead and customize this to work with our application. So this is going to listen on the port 80, which is like the open port of our server, through which all requests will be made from all clients that will make requests to our server. So we have to change a few things here. We can put the IP address of our server or the domain on which we're accessing our server. So all this information is accessible right here. We don't have to cram it, or basically we don't have to like cram it. We have to just come and copy it here. So I'll go ahead and copy it, and then I will come app here in our terminal. I will go ahead and paste here. So this is going to be the domain name without the www thing. So I'll then go ahead and use the same thing. So I'll remove this part of the domain, paste in the domain. So let me make this a little bit smaller for you guys to see. And then I'll get rid of this comment. Okay, so yeah, now let's go ahead and try to, so if let's say you have static files you want to deploy or you want to set up, this is the command you're going to be setting up, or this is the specific configuration you're going to be setting up. So if you have like all of them accessed on /static, then you'll point to the static directory on your server or something like that. But since we do not have that, we're going to be safe. So yeah, that's going to be it. And now we also see this part right here. It's very important. All the traffic that will hit the slash endpoint or the root endpoint will be proxied or be moved to our localhost 8000, which is running inside our server. So this is the specific setting for that. And then we see some headers being set right here. We have our host, the real remote IP address, and a bunch of other settings. So what I'm going to do is to go ahead and save this file and quit the file. And now we're going to go ahead and do a bunch of stuff right here. So first we're going to set a link, or what do they call it? It's like a link or a hard link to a specific file, which is the one we've created. And we're going to create that hard link inside the sites enabled directory. So I'm going to copy this command right here. And then so this will be /API because that's what we've named it. And then we shall just leave the command as is. So what that will do is to create a link to this file we've created inside the etc/nginx site enabled file. And then through that we'll be able to sort of like be able to expose our localhost 8000. So we need to go ahead and now just restart Nginx, and we shall be able to go ahead and run our server. So another thing is maybe to disable the default settings. So the default sort of like app that's displayed by Nginx, once we've exposed the once we run Nginx on our server, is going to be found in Nginx default. So I'm going to go ahead and also remove this. And now I will go right here, paste this, and that will be good to go. So we're going to perform a bunch of stuff where we're going to restart Nginx. So I'll run Nginx-t. Let's see what that does. If I do Nginx --help, so I need to sudo Nginx. So that's sort of like running an IP and a web server. So if I do -t, we'll get that. So first, could not build optimal proximal or prox headers hash. You should increase that. The configuration file, that syntax is okay. The configuration, that is successful. So we are good to go. Now we're going to restart Nginx with this command. So this tests the configuration, and then this restarts Nginx. So now we can go ahead and access our app to see if our server has been exposed. So if we go back here, I'm going to copy this domain right here and head over to an empty tab, paste it in here. And now we see our hello world being exposed right here. So if I go to localhost 8000 or our server's domain right here, we're now going to go ahead and see docs. The docs endpoint is here, so we can make some requests. Let me try sending hello world. That is hello world. And if I try to send this, and now see the about page request being returned. So I hope you've enjoyed this. There are of course some considerations that you'd make in case you take your security serious. One of them is to hide your Swagger docs. So let's go back. I'm going to go back here, and what I'll do is to go and vim into our main.py, which is our app folder or our app file, and then and to go ahead and change or hide our OpenAPI docs. So what I'm going to do is to come right here. Let me take you to VS Code. In VS Code, if I take you to our app instance or our FastAPI instance, let me make a VS Code be in knowledge of where my virtual environment is. So I'll browse, show it that we have, this is interesting. We have simple Flask deployment, but it can't see the Vim folder. Oh, I have a Vim folder right here. Why can't you recognize it? Let me open this, go here, browse. I still can't see my virtual environment, so that sucks. But the thing is, in our FastAPI instance, let me try to actually go to Vim, lib, and site packages, and then go to FastAPI. We have our FastAPI class, and it has a bunch of stuff in it, but one of the things it also has is documentation for the different options we can provide to the FastAPI instance. Now, what I'm looking for is the setting that disables the Swagger UI. I'm going to search for OpenAPI. So this will be the title. So this is going to be for the title, the summary, the description, the version, the OpenAPI URL, the URL where the OpenAPI schema will be served from. If you set it to none, no OpenAPI schema will be served. So yeah, by default, this will be a string on none. If we set it to none, no OpenAPI will be served publicly. So that means we shall disable our OpenAPI documentation. So that's one of the things we can do. If I go back to our server right here, I want to go ahead and disable that because we are in production. I'll say OpenAPI. Oh, is that open underscore API? OpenAPI URL. Yeah, OpenAPI underscore URL. And then that will be none. So that's what I want to add here. And then you can add the description, the title, and the rest of those things. But I feel like you've got a feel of what it means to deploy something on a Linux machine. Let us try to restart our server. So I'm going to save this and then get out of here. I'll rerun the command sudo system control restart and then api.service. So hopefully that will restart our service. If I try to search for the logs, I'm trying to access our logs. So I'll go to journal CTL. -u API. So application setup complete. Let us try to see if OpenAPI is disabled. If I come back to our server right here and restart, we now see that that has been disabled. So yeah, that's how it works. That's how you can deploy FastAPI to a Linux machine using UV, using Uvicorn in the background through the FastAPI CLI. And yeah, basically that's what the video is about. Hi everyone, Jonathan here. If you've liked this video, please click the like button. Do not forget to subscribe to the channel if you're new. I'm going to be making another video about the FastAPI cloud. I got my email telling me that the FastAPI cloud is now ready, and I'm one of those people who joined the waitlist, so I'll be making the video about that as well. If you've enjoyed what you've seen, click the like button. Do not forget to subscribe if you're new. Leave me a comment down in the comment section, giving me any questions, comments, concerns, and all that. Thanks for watching, guys. I'll see you in the next video. Bye.